There is a frog with skin so clear you can look right through its belly and watch its heartbeat. There is an octopus made almost entirely of see-through jelly, with only its eyes and a few small parts you can actually spot in the water. And there is a fish with blood that has no red color at all, because it has no red blood cells inside it. These are not tricks. These are real animals, and they all evolved the same basic goal: become as close to invisible as possible. But turning your body see-through is not easy. Most animals are full of parts that are hard to hide. So how did some animals actually pull this off? Let's start with the biggest problem first. Almost everything inside a body gets in the way of light. Bones, muscle, blood, organs, they all block light or bounce it back in different directions, and that is exactly what makes something visible in the first place. To become truly see-through, an animal has to solve this problem piece by piece, almost like removing every reason light has to stop and bounce off something solid. The first trick many of these animals use is simple: get rid of color. Most animal skin and body tissue is see-through on its own more than people realize. What actually makes something visible most of the time is not the tissue itself, but the pigment sitting inside it, the natural coloring that gives skin, scales, or shells their color. Many see-through animals have evolved to simply not produce much pigment at all in large parts of their body. Less pigment means less light gets blocked or reflected, and the body starts to let light pass straight through instead. But removing color is only the first step, because plenty of animals have pale, light skin and are still fully visible. The bigger challenge is what is happening underneath that skin. This is where blood becomes a major problem. Blood is thick, it moves constantly, and in most animals it is bright red because of a substance called hemoglobin, which carries oxygen through the body. Hemoglobin is very good at its job, but it is also very good at blocking light, which makes blood one of the hardest things in a body to hide. Some fish living in extremely cold waters solved this problem in one of the most extreme ways found anywhere in nature. They evolved to stop making red blood cells almost completely. Their blood runs almost clear, carrying oxygen in a different, less visible way instead. Cold water naturally holds more oxygen than warm water, which is part of what allowed these fish to survive without depending on the usual method most animals use to move oxygen through their bodies. Losing the red color of their blood came with real costs, but in their icy home, with fewer predators counting on spotting a splash of red, it turned out to be a trade worth making. There is one more part of the body that almost never fully disappears, and that is the eyes. Eyes need to catch light to work at all, which means, by their very nature, they cannot be fully seen through the way skin or blood can. This is why, even in the clearest glass frog or the most transparent glass octopus, the eyes are usually the one part you can still spot clearly. Some of these animals deal with this problem by keeping their eyes very small, or by placing them in a spot on the body less likely to catch a predator's attention. Others simply accept that this one part cannot be hidden and rely on the rest of their transparent body to make up for it. It is one small but honest limit on just how invisible an animal can actually become. Other animals took a completely different approach and focused on where they hide their less transparent body parts instead of trying to make everything clear at once. The glass frog is a great example of this. Most of its body really is see-through, especially around its belly, but its internal organs are still there, and they are not naturally invisible on their own. During the day, when the frog is resting and trying to stay hidden from predators, it can actually pull most of its red blood cells out of its bloodstream and tuck them away inside its liver. With fewer red blood cells moving through its body at that moment, the frog becomes even more see-through than usual, right when staying hidden matters most. Once night falls and the frog becomes more active, the blood cells move back out and its body works normally again. Then there is the challenge of light itself and how it moves through water compared to air. Water bends and reflects light differently than air does, so an animal trying to disappear in the ocean needs its body to bend light in almost the exact same way water already does. This is called matching the refractive index, and it is one of the trickiest parts of true transparency. A jellyfish, for example, is made up mostly of a soft, watery material that behaves very similarly to the water around it, which is a huge part of why jellyfish can look like they are barely there at all, even in perfectly clear water. So why go through all this trouble in the first place? The answer comes down to one simple advantage. In open water, there is nowhere to hide. No rocks, no plants, no shadows to duck behind. If you are small and swimming out in the open ocean, your only real defense against being eaten is to avoid being seen in the first place. Camouflage that matches the sand or the rocks does not help much when there is nothing around you but empty blue water in every direction. Becoming see-through is one of the only strategies that actually works in an environment with no natural hiding spots at all. This is also why transparency shows up so often in young or small ocean animals, like baby fish and tiny floating larvae, more than in large, fully grown predators. Staying hidden matters most when you are small enough to be easy prey and too weak to fight back. Once an animal grows large enough that most predators leave it alone, the pressure to stay invisible naturally fades. It also shows just how many separate problems had to be solved at the same time for any of this to actually work. Getting rid of colour alone would not be enough. Hiding blood alone would not be enough either. It took many small changes, each one solving a different piece of the same puzzle, all lining up together in the same animal before true invisibility became possible. So when you put it all together, animals did not become see-through by accident. It took losing colour, hiding or changing their blood, and even bending light the same way water does, all working together at once. It is one of the most extreme survival tricks in nature, built entirely around one simple idea. If nothing can see you, almost nothing can catch you either.